This question is asking you to find the maximum possible area of a rectangle with a diagonal length of 7. So to find the maximum possible area, you just want the sides to be as close as possible in value, and they can also be equal in value. So this square rectangle will give you the maximum possible area. And you can see that this will be the biggest, well, this will be with the largest area, since even if you drew this rectangle, which also has a diagonal of 7, it's clearly smaller. It clearly has a smaller area than this one. So now we just want to find the area, and since we know that both sides are x, then we know that x squared plus x squared, or 2x squared, is equal to 7 squared. And conveniently, x squared is also the area of the rectangle, so we just divide both sides by 2, and we'll get 49 over 2, and that's our answer. Question 2, what is the last digit of this number? So this is, for this problem, you have to find a pattern in the ones digit, the last digit. So let's just write out all the values of this and see if we can find a pattern. So 3 to the power of 1 is just 3. 3 squared is 9. 3 cubed is 27. So far there's no pattern yet, but let's continue. So 3 to the power of 4 is 81, and 3 to the power of 5 is 275. And as you can see, you go for the last digit, you go this, 3, 9, 7, 1, and then you go back to 3 again. And that's when you know that you can end this, and you know that this entire thing will be your pattern. Since even if you do 3 to the power of 6, it will end in 9, since 273 times 3, you just know it's 9. Oops. Okay. So basically the pattern for the last digit is 3, 9, 7, 1. And now we just divide the exponent 2014 divided by, it might be this. It might be 245. I don't know. I didn't really calculate it. So now we just divide 2014 by 4, since there are 4 digits here. And you'll get something like 503 remainder 2. And this remainder is going to tell you that you go 1, 2, that this second digit in the pattern, 9, will be your answer. And that will be your last digit. Okay. Question 3. So for this whole picture is quite complicated, and it's just easier to look at it if you just look at one section of it. So we're just going to look at this corner section, and the blue thing I outlined here is just a square. It's 1/9 of the entire square, and there are actually 9 of these, so they're all the same thing. So okay, so first of all, we want to find the percent of the plane that is enclosed by pentagons. So this thing, okay, let me just shade it in. I'll shade it in with green. These are your pentagons, okay? And we want to find the area, well, the percent that it covers. So first of all, if we let this entire length be called 3a, so we're going to assume that the squares, these tiny squares, have side lengths of a, and we're also going to assume that this length is also a, so you get 3a. So we know that the area of the blue square is 3a squared, and we also know that the area of these smaller squares is a, and there are 4 of those, so that gives you a total of 4a. And if you do subtraction, you'll get 4a squared. You'll get 9a squared minus 4a squared. That's just equal to 5a squared. And we know that this 5a squared will just be the area of all these green pentagons. So now we just found the area, okay? And now we have to find the percent of the plane that is covered by pentagons. So we put the area of the pentagons on top and divide that over the total area of the square, which is 9a squared. Well, we don't know that the base of the pentagons is equal to the side lengths of the square, but we're just going to assume so since there's no restriction. Well, the problem gives you no restriction. So 5a squared divided by 9a squared is just 5 over 9, also known as 55.55 forever percent, and that is your answer. Yeah, you don't have to solve for the rest of for the entire square, since the blue square is just the same as the entire square. So, well, you can round if you want, but depends on the situation, I guess. Question 4, yeah. Oh yeah, these last 2 questions are pretty tricky, I think. So this question wants you to find the number of positive integers that are not past 2001 that are also multiples of 3 or 4 but not 5. So first of all, you have your number 2001. And 2001 is a multiple of 3. So we're just going to leave that there and ignore it. So then we're just going to look at the rest of the numbers. The rest of the numbers 1 to 2000. And first of all, we know that there are 2000 numbers between 1 and 2000. So we also know that 4/5 of these numbers are not multiples of 5, since for every 5th number it's divisible by 5. So that's equal to 1600, 1600, and this is just the numbers that are not multiples of 5. Okay, so we also know that 2 out of 3 numbers, for every 1/3 number, for every third number, a number is divisible by 3, so that means that 2/3 numbers are not divisible by 3. And we use the same logic for 4. 3 out of 4 numbers are not divisible by 4. And we're going to multiply this by 1600. So that gives us 800 numbers that are not multiples of 3 or 4. So that means that there are 1600 minus 800, or 800 numbers that are multiples of 3 or 4. And since we also have the number 2001, we're going to add 1 to that for your answer of 801. Yeah, if you didn't get this, that's okay. This last question was also kind of complicated. I think, yeah, complicated, maybe. Okay, so if you want the medium of all of these numbers, then you want to find the 20/20th number and the 20/21st numbers. You're going to want to find those numbers. The answer for the last problem was 801. Okay, so you want to find these numbers. So first of all, we know that 44 squared is equal to 1936. And that just means that 1 squared, 2 squared, 3 squared, all the way to 44 squared, these numbers are between 1 and 1936. So, yes. So we know that 1936 plus 44, this 44 comes from this. There are 44 terms in here. So the 1936 comes from 1 to 1936. There are 1936 numbers between this. So if you add these together, you will get 1980. 1980. So that just means that 1936 or 44 squared, they're actually 2 different numbers, but in this case, we'll just pretend that 1936 is after 44 squared. So we can say that 1936 is the 1980th term. Okay? And that just means that there are 2020 minus 1980, or 40 more terms that you need to find before you can find the 20/20th term. Okay? So we also know that 45 squared is equal to 2025, and that is bigger than 2020. Okay? So that means that we can just ignore it. So that means that the 20/20th term is